a lot of stuff about parabolas today. Many things we know before. Are we cool with like parabolas that open up or open down? You know, like this parabola right here, he opens up, right? And the other one opens down. It's about the A value of that guy when we talk a little bit later. But here's what we care about. We care about increasing and decreasing at the very beginning of this guy. So I'm not trying to insult anybody's intelligence. I've taught this for a long time. And there are many students who struggle with increasing and decreasing. So I'm going to use a highlighter right here. What do you feel about that green zone right there? If you only looked at that, you have to read all graphs from left to right. You do not get to read graphs up and down. You go left to right. Is this green part increasing or decreasing? It is decreasing. Cool. And then this dude right here at the vertex, it kind of turns around. That is known as a turning point on a graph. Doesn't it turn into increasing when I go into the red highlighter? What we have a hard time is writing the interval where that happened at. So the decreasing, I'm going to start with it. Let me get my straight edge over here. You do not get to go up here. It doesn't work. You have to go over here. Like, would this straight edge, if I read from left to right, would the green thing run into my straight edge over here at negative infinity? So it's decreasing from negative infinity all the way to 0 in that spot. Are you cool with that? You have to read from left to right. So here's the weird part, where that was decreasing from negative infinity to 0, is it actually decreasing at 0? What do you think? I'll throw this little apple right here. It's going to go up and then it's going to come back down. Ready? Like, didn't it increase and then didn't it decrease? When it got to the vertex, it was not going up and it was not going down. For a microsecond in time, it had to just be at its maximum height. Is that cool? So when it turns around, it is neither going up nor going down. So you cannot include 0 in the decreasing part. Like, it is not decreasing at 0. It's turning around at that point. So where does it increase from? You got to go from left to right. So doesn't it start increasing at 0, and doesn't it just keep on keeping on to the right from 0 to where? Infinity. And you do not put a bracket on either one. It is not increasing nor decreasing at 0. So there's 2 more of those. Let's try one more that I'll do with you. This guy is decreasing here. Get that decreasing interval for me. Check it with mine. And then it is increasing here. And what just messes people up is they want to go like low to high, like with the y values. It has nothing to do with the y. That's not 0, it's 2. I'm sorry. Thank you for that. I saw everybody's face go, what? It's at 2. Does that sound okay? Why not 3? Why not 3? Why did I use 2 instead of 3? 2 is which value, x or y? It's all about the x's, man. It's all about the x's. So doesn't this increase from 2 to infinity in that case? Right? It's only about x's. So do the last one, man. Get that guy increasing and decreasing. Don't have to highlight stuff. Some people think that helps them a lot. The increasing part goes from negative infinity to 3, and the decreasing goes from 3 to infinity. This one is the decreaser. It's like this kind of backwards style. It's weird. In the many semesters past, these have been the most missed questions on this Unit 2 test, you know, the increasing and decreasing, because we get them confused with domain and range too much. Then let's just talk about if a function is quadratic. It's kind of a weird time in the chapter since we've already done a bunch, but they want to know, hey man, is this guy quadratic? Here's how you know. The biggest exponent you see in the function is a 2. It's not a 3, and it's got to have a 2, right? It can't even have a 1. What do you think about this guy? Is he quadratic or not quadratic? So he is not quadratic. The answer to part A is no. They say determine if this is quadratic. And then you notice it says, if it is, do part B and C. We cannot do part B and C due to the fact that this is not quadratic. So, and number 2, I think we kind of gave the cat out of the bag, is this guy quadratic? Yes, it is. The biggest exponent you see is a 2. I hope you know that all quadratics make parabolas when you graph them. We were talking a little earlier, if the parabola opens up or down. Are we down with the fact that we got like y equals ax plus ax squared plus bx plus c, and we know who our a, b, and c values are? A value right here tells you if this guy opens up or opens down. That A value is negative. So which way will this parabola open? Down. What I do is I make a little helper boy sketch. Boom! There is a parabola that opens down. Because they asked me, does he concave up or concave down? We're going to say concave down. Don't know how homework's going to say it. This is the old homework program's way to do it. Concave up, concave down. It might just say open up or open down, which is the normal way. And then the reason why I made this little sketch was to see if that had a maximum or a minimum point. There's the vertex. Is he a maximum or a minimum in that situation? That's a maximum, which is the exact opposite of what your brain thinks when you say concave down. It's like you would think minimum, but that's why I make a little sketch so my eyes can see it, right? So pretty basic stuff there. Then we get into the two forms of the quadratic, the standard form and the vertex form. Standard form we've been dealing with many times. That's all the stuff that we've been factoring and solving all these. And then vertex form, if you remember back to your Algebra 2 days with like the purple note card, you know, it's like it's the basis of the purple note card, that vertex form. So here's the cool thing about the vertex form. The reason why they call it that is you could just totally look at that equation and see what the vertex is. The vertex is always at the ordered pair h comma k. You see h is in here, but oh no, he's got that stupid little minus in front of him. So just like your purple note card days, it's the opposite of what you think right there for your x value of the vertex. And then your y value of the vertex is just at this k right here. So check it out. This old boy, boom, 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 is in vertex form. State the value of the vertex. Here's the x value of your vertex. If I can get a highlighter. Here's your x value of the vertex. Here's your y value of the vertex. I'm going to call them h and k. But the question is, who is the h value? Is he 10 or is he negative 10? Negative 10. This guy, since there is a plus in front of it in that formula, what you see is what you get, so negative 6. You can just look at that dude right there and see the vertex is negative 10, negative 6. So one more of those with you. Who would be the vertex on this guy? What do you want here, 3 or negative 3? Opposite of that dude. And then 1 or negative 1? He is a 1. Cool. Those were the easy ones. Then they try to trick you with the next guy right here because they're like, Miss Fosdale, there is no number right here being added or subtracted to x. And I go, there pretty much is. How do you feel about that being like x plus 0 in the parentheses right there? So what is the x value of the vertex, which is known as h? 0. And what is the y value of the vertex, which is known as k? 2. In my opinion, you should not miss those questions on homework after you've done 1 or 2 of them. Watch your signs. When you see how many questions homework is today, that's because some of them are so fast, it's like, what's the vertex? What's the vertex? What's the vertex? It takes you like 5 seconds to do the problem. You know what I mean? So don't get overwhelmed with how many questions there are. Okay, here's where the not so fun part comes in. Taking some information and writing this guy in vertex form. And I know you have done this before, but I'm going to do the first one like you have never done it before. In this vertex form formula, there are 5 different variables. Y, A, X, H, and K. You see there's 5 different letters in there. What they have given us here is a point right here and the vertex. They have given me 4 of the 5 things. Please write with me. On this point right here, he's just plain Jane bananas, x, sorry, that didn't work, x and y. They have given you an x, they have given you a y. When they give you the vertex, yes, it is an x and a y value, but specially, he is h and he is k. Are you with me on that, on the vertex? Do you see that you have x, y, h, and k? Out of these 5 letters, who's still missing? We don't know a, right? So what we do is we'll substitute all 4 of these dudes in here. So I don't care if you write this guy down or not. You do have to memorize that formula, by the way. And let's roll with it. It starts with y. Isn't y? 0. Are you guys with me on where I had that? Y is 0 equals a. I don't know him, so I'm going to totally start with an a. Then parentheses, x is 4 minus h, which is 2. That quantity gets squared. And then plus k, please write minus 4 instead of plus negative 4. Are you guys cool with where I got those numbers and why I put them where I put them, right? X, y, h, and k. Let's follow the order of operations, which is way more challenging than you think, dude. We should do what's inside the parentheses first. Inside here, 4 minus 2 is how much? 2. And then doesn't it get squared after that, correct? 2 squared is 4. Could I beg you to write it like this? Do not put a times 4. Do not put that. How is it better to put a times 4? Put 4a. Put 4a, and then there is a minus 4 after that. Are you with me on that? Like, instead of doing that, because here's what happens. People put a times 4 minus 4, and they think they could subtract those freaking numbers right there. And you can't do that because there is multiplication going on between there, and you're violating the order of operations. Your brain will never do that to you if you write this properly, if you write it as 4a instead of a4. Cool? So now let's solve for a. I got to move this minus 4 over. So I will add 4 to both sides, and then I'll divide by 4. And a turned out to be 1. Do not feel that you have finished the problem there. You have found one of the missing ingredients. We have found a. To write an equation in vertex form, to write a parabola in vertex form, you need 3 ingredients. You need a, h, and k. We had h and k given to us up here. We just found a, so your final answer, you start all over and do y equals a times the quantity of x minus h, quantity squared, plus k. I doubt that they're going to make you put the 1 on homework, but if it is any other number besides a 1, you'll have to put it. Do you see how I took the generic formula of vertex form and substituted in a, h, and k? Most missed thing on homework, forgetting that little dude right there. I don't know why my pen won't grab that highlighter. I'm so sorry about it. But forgetting to put the little squared dude right there. It's like, oh, my bad, you know, forgot the squared. So let's do that again. Please work with the neighbor and figure out who x and y is and who h and k is. I'll let you pause video, check it in. So here's x, y, here's h, k. Now I'm going to sub in 7 equals a times minus h, quantity squared, plus k. Do what's inside the parentheses first. You get a negative 2, but that has to get squared. So that will turn out to be a positive 4. Again, switching them around to where it's 4a instead of a4. And then just solving. And the optical illusion, once again, bites a lot of people. Does that turn out to be 2, or does that turn out to be 1/2? Yeah, watch out. Everybody sees it. You know, your brain just kind of like, oh, my bad. I did 4 divided by 2 instead of 2 divided by 4. So write your equation in a vertex form. You need to sub back in a, you need to sub back in h, and you need to sub back in k. That is the answer on homework. Remember that? That's been a while since you did it, but you've done that a few times before. Why did I do it this way? Because they gave me 4 of the 5 variables. Cool. Then let's switch it up, man. They want us to write the equation in vertex form, but they gave it to us in standard form. I even wrote these homework questions myself. So like when you do these today, these were written by me. They're going to make you do 3 things first. I would like you to do this on paper too. We need 3 ingredients. So let's start with a equals, h equals, and k equals. A equals, h equals, and k equals. You will be required to do that on homework anyway. Let's start learning to do it on paper. And the cool thing is, it's amazing that many students freak out and they're like, how do you know what A is? And I'm like, oh man, they literally told it to you right up here. This is the same parabola in standard form. You can see A, you can see B, and you can see C. Which one's A? 2. A is 2, right? And then I'm sorry that this is on the wrong side of the paper, but if you flip back over to back here, I've got notes for you of how to find the x value of the vertex when you have this guy in standard form. There's a little bitty formula called the opposite of b over 2 times a. You've done that many, many times, and I would like to honestly tell you the secret. That is the secret to this test. If you can find the x value of the vertex, you will do awesome on this test. Please remember that the h value of the vertex is the same as the x. I personally think if you write it down every time, you'll start remembering what to do. So it's the opposite of b over 2 times a, which is a huge part of this test. B is negative 8, so isn't the opposite of that 8? Are you with me on that? 2 times a is 4. And yes, you will simplify that. What's 8 over 4? 2. This is the x value of the vertex known as h, right? And then how do you find the y value of the vertex, such as k? You take this 2 and you substitute him in for x. And if you put it in parentheses, you'll never get it wrong. Let's substitute stuff in parentheses. Grab ye old calculator and type literally what you see, but where there is an x, you are putting 2 in parentheses. And if you don't think the parentheses matter, I'm not kidding. On this one, they won't. On this one, the parentheses won't matter. But I'll bet on the next one they do. What did we get for a k value? -3? Nice. Using parentheses, you should never get that wrong unless you accidentally type it wrong, of course, but -3. Now, can you write the equation of the parabola in vertex form, knowing that you have a, h, and k? So homework will make you do those 3 phases first, and then you've got to actually write the parabola. So that would be y equals 2 times the quantity of x minus 2 squared minus 3. Because it's the opposite of what you think inside the parentheses. What you see is what you get right there. Cool. One bonus question for you, because it's going to happen this chapter anyway. Does this parabola open up or open down? I didn't even graph it, but I can tell by looking. Does it open up or open down? Opens up, because isn't that a value positive? Cool. So let's do that again. Start with a, h, and k. A, h, and k. A is a free money situation. They told it to you to start with. H is the opposite of B over 2 times A. And finding K, again, if you struggle, like next week, it's like, how did we do that again? I'll tell you, just not on test day. But you take -5 and you put him in for X, and yo, it's going to make a huge difference now if you use parentheses or not, because that's a negative value. Please make sure you put him in parentheses. The parentheses take care of all your negative woes. -3 using parentheses times -5 squared minus 30 times -5 minus 73, right? And I got 2. Did you get 2 back on that, dude? If you don't use parentheses, the negative number squared just usually doesn't come out what it's supposed to be. So, final answer, y equals a times quantity of x minus h, so opposite of what you think right there, and then plus 2. Yeah, it's always, this dude right here is opposite of that guy. You've done that quite a few times before also. You might not remember it, but you have. Questions for me? This is something you've probably very rarely done. That is in vertex form. They want you to write it in standard form. So what that means is we got to multiply it out. So here we go. Y should equal 2 times. We learned this last chapter, so I'm not going to harp on it too much. You have to FOIL this out. It's x plus 3 times x plus 3. You don't just get to square the x and square the 3. You got to FOIL it out. Would you like to learn a shortcut to how to FOIL a binomial where you don't have to do all this work? It's called square the first guy twice the product, square the last guy. So watch this. I'll just do it off to the side. Who's the first guy in these parentheses? It is x. Square him. What do you get? X squared. Then when I say twice the product, that means take these 2 nugs right here, the 3 and the x, and multiply them together. Don't you get 3x? Now take twice that. What would that be? 6x. Then you square the last guy. To square the last guy, it's 3 squared. Isn't it a positive 9? That's what that will turn out to be. Why does that work? Because if you FOIL this out, you get x squared plus 3x plus 3x plus 9. This is where twice the product comes from. It's like you're going to have that twice when you FOIL it out. It's always going to be this dude and this dude right in a row because you're taking the same stuff times each other. So back to where we were. If we want to take that shortcut, this is 2 times x squared plus 6x plus 9 in parentheses, and there is a minus 6 afterwards. Now we got to distribute the 2 through. So 2x squared plus 12x plus 18, and there is a minus 6, and then You add those like terms together at the end. 18 minus 6 is a 12. That is the equation of that same parabola in standard form. Would you try that on 11? See if you can get that binomial squared done. Square the first guy, twice the product, square the last guy. Square the first guy, twice the product, square the last guy. Square the first guy, x squared. Then I have to do this in 2 moves. Like, I can't do twice the product in 1 move personally. I have to multiply them together. It's negative 2 times x, which is negative 2x. Then I double that. Shouldn't that be negative 4x? Then square the last guy. Be very careful. What's a negative 2 squared? Is it 4 or negative 4? It's positive 4. If you don't like that, FOIL it out, dude. You know, if you're like, I do not like that, cool. Write them side by side and FOIL it out. First, outside, inside, last. Then distributing that half through. Don't care that it's too ugly right there. So 1/2 x squared. The other guys are even numbers, so that's pretty nice. Like half of 4x is minus 2x. And then that should be plus 2, plus 1 more. So I'm just going to erase that and put plus 3. Right. If you want to skip that last move, you distributed and added those together. Cool. That's how you take something from standard form into vertex form. There'll be a different type of one on your homework also that says it's in intercept form. Moral of the story, multiply it all out is all you got to do. Just what we did. Let's just multiply it all out. Okay. And then let's get into this, right? Does this parabola open up or down? I think we're doing good with that. What do you think? Down, because that a value is negative. State the vertex. Crap! Is this in standard form or vertex form? Standard. So how do I find the vertex? Opposite of b over 2 times a. I'll get this out of the way right now. Those of you who use your graphing calculator to find the vertex all the time, this chapter will be difficult because many of them will be way out in no man's land, right? If you can do opposite of b over 2 times a, it will save you a lot of time. So negative 8 over negative 2. Don't you get 4 back on that? What I actually do is I start writing an ordered pair. So 4 is the x value of my vertex. Substitute that home slice in to parentheses. That's a good one right here. You see that you've just got to put parentheses around x. So that negative is on the outside of the parentheses. It's going to be negative parenthesis 4, close it up, square it, plus 8 times 4 minus 15. You with me on that, dude, right there? That negative in front of the x squared is not a part of the parentheses. It's on the outside of it. So what did you do? 1. Boom. State the vertex. Yes, you'll write it as an ordered pair. State the y-intercept. We did that last chapter, man. You just let x be 0. If you let x be 0, that will find you a y-intercept. I will let x be 0. I will substitute that into my brain right here. If I let this x be 0, what does that green nugget turn out to be if x is 0? 0, right? Negative 0 squared is still 0. What does that turn out to be? 0. What's the y-intercept? Negative 15. Cool. Negative 15. You just let x be 0 to find the y-intercept. And then for shorthand, it's that number. That number right there is the y-intercept. State the axis of symmetry. We'll do that after we graph this guy, right? How's that sound? They ask us to graph it. Kind of a crappy situation right here because these points don't fit on here. So what we'll do is we'll use our calculator to make a table of values. So let's punch this guy in, clear all that out. Negative x squared plus 8x minus 15. Clear that. And all I care about is making a table of values so I can plot some points. So I do want to like hover around my vertex because parabolas have symmetry around the vertex. So do you see the vertex was at 4, 1? I'm going to go plotting 4, 1 and then a few points on either side of it. 4, 1, bada boom. And then it looks like 5, 0, 5, 0. And then what's the other guy here? 3, 4, what? 4, 1. How about we plot that right, Mr. Farnston? Not 1, 4, 4, 1, 3, 0. And then 2, negative 3. 6, negative 3. Can I squeeze another one on there? Yep, I can get to negative 8. So 1, negative 8, and 7, negative 8. Then just do your best little freehand to freehand those together. When you graph the parabola on your homework, plot the vertex first. Boom, you got to plot that point. Then one more point. You just do one more point. Use your table of values from your calculator to find one more point. If the y-intercept would have fit on the graph, I would have plotted it, and I wouldn't even have had to use my calculator, but the y-intercept didn't fit on the graph. In that case, it's down off too low. But they asked us about the axis of symmetry. You might not even remember doing that from your algebra days. If I drew this line right here, a little better, let's try that one more time. If I drew this line right here, is everything on the left side of this line symmetrical to everything on the right side of that line? Cool. That is a vertical line right there. So its equation will be x equals. And where does it go through? The vertex. Isn't it at 4 in that case? Isn't that the x value of the vertex? So when they ask for the axis of symmetry, though, realize it's not just 4. It's got to be a line. It is the vertical line x equals 4. Groovy? Make sense? Yes, no, maybe? All right. Keeping on, keeping on. Now, the winner of this chapter, taking some nasty quadratic dudes and finding a good window for them. Right? So here's what you'll waste your time doing. You'll waste your time hunting for a good window. The secret is find the vertex first with algebra. Let's find the vertex first with algebra. Is this in standard form or vertex form? Standard. Find that vertex for me. We'll do a little x equals, opposite of b over 2 times a. I think the more you write that down, the easier it is to remember what to do. Right? I need opposite of b over 2 times a. 40 over 4, which is 10. I'll give it a 10. Substitute 10 in and find the y value of the vertex. I got negative 190. Is that what you got? Very likely to happen. Way off the grid. You would have to look for a long time. Zoom Fit probably doesn't work very well, just in experience. If it did work well, I'd show you to use Zoom Fit, but it just doesn't work that well. So they ask us to find a good window to graph this guy in. Here's what I want us to do. I know you don't have much room on your paper. Sketch a small little rectangle like this. That is the window of your graphing calculator. Like, what that means is that's like your calculator screen. This is called the window. Are you okay with it? The screen of your calculator. Here's a rule to make a good graph of a parabola. The x-axis and the y-axis have to be on screen. Otherwise, it's not a good graph. You need x-axis and y-axis on screen. So here's how I find my, so like this is like x-min right here, and this is x-max, and then y-min and y-max going up and down. But let's deal with x-mins and x-maxes. All you do is this. Bing. Focus on the x value of your vertex. Isn't he like 10? Are you with me on that? I like him to be roughly in the middle of my graph. And which way does this parabola open? Sorry, that's another key to this. Up or down? Which way is up? So I'm hoping for this. Put a little dot right there. I want that x value to be at 10, to be like in the middle of my screen. So could you tell me if that's roughly like halfway? And of course, you know I need my x-axis and y-axis. I'm going to put like the y-axis to be right there and my x-axis to be like right there. How far is this from, is 10 from the y-axis? Say 10. How far is 10 from the y-axis? Isn't it 10 units away, right? So what I would like this, for this to be roughly symmetrical, is that distance right there to also be 10 units away. Are you with me on that? So if I'm at 10, and I need to move 10 units to the right of it, where would I go to? 20. That's what I'm going to set my x-max at for a rough draft, at 20. Here's the problem, though. If I set this at 0, I'm not going to be able to see my y-axis. So I need to put one more tick mark to the left. So here's a cool thing that we need to do. Let's figure out what you would count by. If you had to go from 0 to 20, like on paper even, would you count by ones or would you count by something different? What would you count by? 2s is good. You know, let's count by 2s. Does that sound okay? So if we're counting by 2s, and I want to go one tick mark to the left of it, so if this is 2, 4, 6, 8, 10, 12, all the way up to 20, who the hell is that? Who is that if I'm counting by 2s? Isn't that negative 2? That's my x minimum right there, is negative 2. Let's start putting this in our calculator. We got to, of course, type the function in, 2x squared. Clear it all out first. 2x squared. You're going to have to graph it anyway, so type with me. Minus 40x plus 10. So we're going to then go to window, and we're going to change our x minimum to who? Who did we want our x minimum to be? Negative 2. X maximum was 20. And the scale, that's what that SCL is. The scale, we're counting by 2s. Are you cool with my x's? That, to most students, is the hardest part, is finding the x min and the x max. Because the y min and the y max is really, 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 really pretty nice, right? They want to know, like, where the vertex is. Well, I kind of messed up my picture already because I wasn't thinking that far ahead. But shouldn't this parabola, it opens up, right? But the y min is at negative 190, so it should be like this. I don't know why I put that y-axis. I want this to be at 10, negative 190, and the parabola opens up. So my x-axis is going to be way up here, and my y-axis is going to be right there. I need to get all the way down to negative 190 on the y-axis scale, because that's my y minimum. I don't want to go down to negative 190. Who's a nice, neat, round number that you could probably go to? Not quite 200, but negative 200 is what you got to go to. Wouldn't that be the y min, right? So negative 200. What would you count by if you had to go down to negative 200? There's quite a few options. Here's some decent ones. 10s is a little too much. That's 20 tick marks I got to put, you know. So counting by 20s is good. Counting by 25s is good. Counting by 50s is good. Are you with me on that? Let's count by 25s. Let's count by 25s. So here's what I got going on so far. This is way down here at negative 200, and I want to count by 25s. So on my picture right here, this is all the way down negative 200. Bing, 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 bing. All of these are 25. What's that one? 1 unit above the x-axis. If we're counting by 25s, what's that guy at? 25. So that's your y max. That's weird. Y max is 25. And let's hit graph and see if that works for us. Is that a pretty decent window of looking at that parabola? It was a rough guess because we might have to make some adjustments on our x-axis scale. Like y-axis shouldn't be a problem at all. But this guy, I do want to see where he intersects the x-axis at, and I barely saw him. If I need to make a little adjustment and go over to like 24 or something, you would, right? That's why the x's is kind of a rough guess at first. See if it worked. Maybe it didn't. So when they asked what's the window, here's what we did. We went from negative 2, this is how you write it, to 20 by 2s. And then you go by, our y min was negative 200 to 25 by 25. That's what they're looking for when they go, what's a good window to do this? X's come first. This is x min, x max, scale. Y min, Y max, scale. Like you got to go in that order. So let's do one more of those. Man, let's find a good window for this guy. Who's the basis of it all? Finding the vertex. Please find the vertex on this dude right here. So I got my x value of the vertex to be negative 11 and the y value to be 375. And then what we'll do is maybe the rectangle doesn't make sense. Maybe we just want to draw like an x-axis and a y-axis. Maybe that could be a new philosophy. How does this parabola open, though? Up or down? Down. He opens down. And I want my vertex to be smack dab in the middle. So at negative 11, 375, I kind of make a little sketch like this. And he's going to go bada boom, bada boom. That's what I'm looking for. So let's find that weird x-axis scale. So right here is where I want symmetry around the vertex. This distance, realize your y-axis is, I'm going to switch colors, is way over here. Right? This is your y-axis. It is 11 units away that direction. Right? Isn't that vertex 11 units away? That orange area is 11 units away. So I want to go roughly 11 units away on the other side. Wouldn't that put me to negative 22? What a dumb number. Let's go a little further. Negative 30 is fine, or negative 25 is fine. Are you with me? Either one, right? I'm going to do negative 30 since that's what you said. I'll go to negative 30 there. And then this guy, how would you count if you had to go all the way over to like 0 to negative 30? I'm not a big fan of counting by threes, even though it's not wrong. It's just weird for people. What would you count by? Fives is fine by me, right? So that means this distance right here is going to be 5, right? Because I've got to go one more tick mark right here. So my x max is going to be at 5. X min at negative 30. X max at 5. And I wanted to count by 5s. So I'll start putting that in my calculator. There's no wrong window. There's just some bad windows. Like you could have went to negative 25 instead of negative 30. Like it's trying to get in the ballpark. So negative 30, 5 by 5. And then the y max. Isn't this y max way up here at 375? So who's a good round number for our y max in that case? 400, right? So I'm going to go all the way up to 400. I would probably count by either 50s or 100s to get there, you know, like one of those makes sense. 25s ain't bad either, but I'd either go by 50s or 100s. So that means your y-axis is way down here at 0. And if we go 100, 200, 300, 400, if we're counting by hundreds, isn't this guy down here a negative 100 in that case? That's really pretty weird. Like, if you need some more help with that, I'm happy to help you, but I wanted to go from negative 100 to 400, counting by hundreds. And again, there could be other windows, but if you look at this, you see the vertex nice and easily. You see both the x-axis and the y-axis, and you see where it intersects those guys at. That is a beautiful window. It's not the perfect window, but it is beautiful, which is compared to this. You know, many students just go nuts and go like negative 1,000 to 1,000. You know, and negative 1,000 to 1,000. Like, I don't know, I'm just guessing. This is going to be a horrible window. Can you see that that window right there is a horrible job of showing what that parabola looks like in this case? Cool. So trying to find a decent window. It's not going to go away. That was negative 100 to 400 by 100s. I think. All right, last one of the day, baby. Lots of word problems on this homework, lots of word problems on your test, right? So last one of the day. If a ball is thrown upward at 39.2 meters per second from the top of a building that is 30 meters high, the height of the model can be modeled by this. I think you all know it. If I throw a ball, doesn't it make a parabola, right? That opens down in that case, correct? Due to gravity. So they threw a ball, and they asked this. It's so simple. There's a sketch here for the end. They say find the max height of the ball and how many seconds. Bro, if you ever graph a parabola that opens down, isn't the max height and all that stuff at the vertex? Yes? So we don't need to graph anything on our calculator. We need to find the vertex. This is almost in standard form. It is definitely not in vertex form, but can't we do the vertex by doing the opposite of B over 2 times A? I'm telling you, it's the secret to this chapter, man. The opposite of B over 2 times A. The question is, B is not an issue, isn't it? Like 39.2, so the opposite of that. But which one's A? Is it 30 or the negative 9.8? Yeah, they got it all backwards, right? So it's the negative 9.8, but you need to do 2 times that. So negative 9.8 times 2, negative 19.6. When you divide that out, if you tell me what it is, I'll tell you what the y value turns out to be so we don't have to punch that in. What did you get? 2? Cool. 2. Then are you down with the fact that you literally need to put 2 in for t to figure out what the y value is? It turns out to be 69.2. It's okay that you get decimals in that situation, but it turns out to be 69.2. Cool? Talk to me, dude. That is not the answer to the question. It's what a lot of people do wrong on the test. They just put the vertex. They want to know what the maximum height of that ball is. Do you see how t is time in seconds, aka your x values, and the height in meters is your y values? They want to know the maximum height. Which one is that, 2 or 69.2? So the answer to this question is 69.2. Put a label on it for me of meters. And part B, it says, yo, bro, how many seconds did it take? Isn't that the x value of the vertex? How many seconds did it take? 2 seconds. So the vertex answered those questions. You just had to interpret it. Why do I have this little sketch here? So we could make a sketch to see where this guy is increasing. Could you also tell me what the y-intercept of this graph is, just to make an accurate sketch? What's the y-intercept? 30. So I'm just going to put like 0, 30 right here. Doesn't this parabola go boom? Like it just opens down, just a rough sketch. And you know that the vertex was at 2, 69.2. It ain't the prettiest sketch in the world, but it's pretty accurate also, just because I put those two ordered pairs on there. It started 30, and then it opened down, and there's my vertex. I will highlight for you what they're asking. They say, over what time interval bing, is this increasing? How do you feel about right there? Isn't that where that is increasing at? Could you write that as an interval? Multiple choice. Is the correct answer A, from 30 to 69.2, or B, from 0 to 2? A or B? How do you always read a graph? From left to right or up to down? And left to right is about x's. Are you with me? So it is not A, it is B. What's the label on it? From 0 to 2 seconds. Cool. That was the longest lesson of the units right here, man.